Okay, so I'm going to go through the rest of 5.3, just a couple of identities and one more example. So when we look at the tangent of 22.5 degrees, this is the same thing as the tangent of 45 divided by 2. I don't know the tangent of 22.5 degrees, so instead of trying to do stuff with that, I'm going to replace it with something I do know about, which is 45. And then use the half angle identity. We have the square root of 1 minus cosine of 2 theta. So 1 minus the cosine of 45 over 1 plus the cosine of 45. And then you can fill that in as you go. So 1 minus root 2 over 2 over 1 plus root 2 over 2, and then simplifying from there. But recognizing that you can use the half angle identity is the biggest thing there. I probably would use one of the other versions on your formula sheet for the half angle identity for tangent if it comes up. But again, you'll have your formula sheet. So just now I used the sine one divided by the cosine one. The 2's go away, square roots, they just both sit under 1 square root. So that's where that came from. Okay, so let's do some identities. I'm gonna split this here. I'm gonna go ahead and write down the double angle identity for sine. So this is 2 sine theta cosine theta. Or if you want to do it as sine theta plus theta, you can go with that too. Double angle. And then on this other side, so I'm going to stop on this side. On the other side, I am going to see if I can do something with this. I think if that looks like it's a Pythagorean identity, so I'm going to check. Cosine squared theta plus sine squared theta is 1. And so if I divide everything by, I want cotangent, so I divide everything by sine. Okay, so then I have cotangent squared theta plus 1 is equal to cosecant squared theta. So I'm going to go ahead and do that. So I have 2, I'm going to change this to cosine over, actually, no, I'm not. Oh, so 2 cotangent theta divided by cosecant squared. Okay, so I'm going to keep going. 2 cotangent of theta is cosine of theta over sine of theta. And then this is divided by 1 over sine squared. So just rewriting these in terms of sine and cosine. Okay, and then I'm going to keep change flip. So I have 2 cosine theta over sine theta times sine squared theta over 1. Flip that bottom and multiply, or think about getting rid of that denominator. To get rid of that denominator, you would multiply by sine squared over 1 on the top and bottom. So like down here, they go away, but then you've got multiplication up top, which is what we have here. Okay, so then what we are looking at is the fact that this is sine times sine. So we have 2 cosine theta times sine theta times sine theta over sine theta. So I'm going to cancel these, and then I have 2 cosine theta sine theta, which is what we're going for. Okay. Now, there are going to be a lot of ways to do this problem. You could instead rewrite everything in terms of sine and cosine to start with, and then you're going to use the Pythagorean identity in its original form, probably to simplify things. But you have lots of choices. This is what I saw, so this is the rabbit that I chased. Okay, so number 6 is easier than that one, in my opinion. When I'm looking at number 6, I see the fact that this sign has 2x in it. These all have just x. So my first thing is going to be to try to get rid of that. And I'm going to use the double angle identity to do that. So sine 2x is 2 sine x cosine x. And then there's still that cosine x that was there before. So this is the double angle identity. Okay, so what we have then is 2 sine x minus 2 sine x, and I'm going to make that cosine squared x. And I am going to take out the 2 sine x. I have 1 minus cosine squared x left. That is sine squared x. Pythagorean identity again, and then that is 2 sine cubed. This is a combine. This is Pythag. This. Oh, no. This is Pythag, that next one. This is a factoring out. And then this is combining like terms or multiplication. Okay. Yeah. You could also, I don't know if this is helpful or not, but you could substitute this right here. So if you don't like the factoring out thing, so you could do this. Knowing that you need to get to something that only involves sine. And then when you do that and distribute stuff, it works out well. Just go there. So whichever makes more sense to you, go with that route. But all right, number 7 is tricky. I have written on here a reminder of what the half angle identity is for sine. The reason is because I see this theta over 2 and I don't like that. So this is going to be, this is the same thing as, let's see, purple, that's not purple. So what we're going to do here is write this as sine of theta over 2, and then the whole thing is squared. So we're actually looking at plus or minus the square root of 1 minus cosine theta over 2, all squared. So the inside part of this is the half angle identity. And so use it, and then that square actually helps us because it gets rid of the plus or minus and the square root. So we have 1 minus cosine theta over 2. Okay, so that looks like a lot nicer to work with. And what I'm going to do then is go on this other side and get everything in terms of sine and cosine. So I have 1 over sine theta for cosecant. Cotangent is cosine theta over sine theta. On the bottom, I have 2 times 1 over sine theta. This is good. So what we're going to do right now is combine the top into one fraction. And then I have 2 over sine theta on the bottom. I am going to keep change flip. So 1 minus cosine theta over sine theta times sine theta over 2. We have sine theta times 1 minus cosine theta over 2 times sine theta. These go away. We have 1 minus cosine theta over 2. Again, the keep change flip thing, if you're wondering about that, you would, to get rid of that denominator, you would multiply by sine over 2. That cancels stuff down here, multiply here. also then by sine theta over 2. And then those signs cancel and you get that down here, which is what we wanted. Okay, so that is section 5.3. Keep in mind, maybe the most important thing is that you might be looking at something on the test that involves double angle, half angle, sum or difference formula, all in a triangle problem. That's a really good thing to know how to do. Let me know if there is anything else I can help you with.